Welcome to Biotosis, everybody. We are here with the Unit 3 of Printing Techniques. Let's get started. So, today we are going to talk about solid based systems. Solid based systems in 3D printing create objects by layering solid materials, okay? And the two key techniques that we're going to talk about today are laminated object manufacturing and fused deposition modeling. So, what are we going to do in laminated object manufacturing is these are going to be solid based techniques. So, what is that? Is that the material that we are going to use for printing will be solid. Okay, so now here material sheet you can see here. Okay, so material sheet is going to pass through these rollers. Four rollers are there, these two blue rollers and this one material supply roll. So the roll is going to pass through it like this. So this is going to function like this. Okay, now this laser is there, laser beam, and the mirror is there to project the dimensions. So we put basic functionality of the 3D printer. We have talked about that we have to put in the CAD model. So the model that we put and with the slicing software, the slicing that we do is going to happen here. Okay, and as we make the whole object, then this platform is going to shift down, down, down. Like the first will be printed, then it will move slightly down, then the other portion will be printed by the laser. It will show what has to be printed, then that layer will be printed, and then the platform will shift gradually more down, and further this is going to happen. Now this heated roller, after each layer has been printed, this will go like this and this will come back. This is going to do the lamination. It is going to heat up so that all the layers are intact and packed with each other. Now that we have understand the whole mechanism of how it is working, let's talk about the technicality. So the model is basically suitable for creating large scale prototypes, handles materials like paper, plastic, and metal foils. So specifications are basically high build speed, layer thickness will be 0.05 to zero point 0.5 mm, maximum size will be determined by the material sheets. Now, so as we talked in the diagram before, so the material preparation is the sheet of the material are prepared and loaded. Okay, once they are loaded, heating, which is basically sheet material is heated for adhesion, like the sticking. Layering is basically layers are bonded by heat by the heated roller. Cutting is layer or blade cuts the layer according to the design that we have provided, and stacking is layers are stacked to create the final shape. After the whole thing is done, post processing is done. Now the working principle is nothing but materials are successfully bonded and cut to form 3D objects. A heated roller facilitates bonding while a laser or blade outlines the shape. What are the applications? Architectural models, automotive and aerospace prototyping, packaging mock-ups, large-scale prototypes for form and fit testings. Now, the disadvantage that is main that we're going to talk about is limited material variety, poor mechanical strength, and post-processing is required to finish the actual product. Otherwise, it has low material cost, fast production of large objects, and minimal material wastage. Coming to the next technique of today, that is fused deposition modeling. Now here what is going to happen is this, as we can see, are like rod like very tiny solid structures which are heated to form a liquid structure, which then turns into a scaffold. So here, from here, solid strands go, and here in the nozzle they come down as liquids, and once that is done, the liquid is prepared in the model that we have provided to the printer, and it is printed. So this is the basic mechanism of working mechanism of the fused deposition modeling. Now, talking about technicalities, desktop and industrial grade printers are there. Okay, these are And the materials that are basically used is PLA, ABS, PETG, nylon, etc. Okay, specifications again 0.05 to 0.4 mm. Build volume you can see and you can refer. This changes from system to system. Now, what is the working process? So, when first we feed the material, which is thermoplastic filament, is fed into the extruder. Again, heating happens. The extruder heats the filament to a molten state so that it can be printed. Now, extrusion is when the molten material is extruded through a nozzle, and layer deposition, like earlier, layer depositions layers are deposited on the build platform, and cooling happens to let the layers solidify. Working principle of this will be FDM uses heated nozzle to extrude molten material layer by layer, and layers fuse as the material cools and creating a solid 3D object. The applications of these are medical prosthetics, functional prototypes, end use parts of aerospace and automotive industries. Obviously, educational models also are many prepared here. Basic disadvantages are slower for large objects. Okay, layer visibility in finished products is not very clear, and limited strength as compared to the other techniques that we have already talked about or going to talk about later. Okay, although it is very affordable and accessible, compatible with various material, and high accuracy of small scale models. Okay, now the conclusion basically says that LOM is cost effective for large scale prototypes, and FDM is ideal for detailed and functional parts. And the future prospects in both techniques will involve material advancement. Okay, so this was all about this unit today. If you have any doubts, please message or comment me below, and the next video will come up really soon. Okay, bye bye. Thank you.